Assalamualaikum and a very good day. We are going to continue our lesson in chapter 3, and today we are going to discuss about power and efficiency. So the outcomes for today's lesson is first to understand the concept of power and derive the equation to calculate power, and also to understand about the efficiency and how it is calculated. And finally, we're going to look at a few example problems involving the calculation of power and efficiency. So power generated by a machine or an engine is the work done. We have discussed about work done in the previous lesson. That is U, or in this case is the change of work done, which is du, within the time interval of dt. So if we write this down, power is basically equivalent to du over dt. And we also know that the work done U is the multiplication of the force and the change of displacement dr. So we can then write the equation again. P is equal to du over dt, which is equal to F times dr over dt, or we can bring F out of this fraction and becomes F times dr over dt. Now notice, what is dr over dt here? Dr over dt is basically the velocity, the change of displacement with respect to time, or the change of displacement over the change of time. So then we're going to have the equation to calculate the power of a machine, which is P equals the force times the velocity. Okay, that is the power. So basically power is force times velocity. And the unit for power is given by watt, or written with a capital W like this. Now let's look at the efficiency. The mechanical efficiency of a machine is defined as the ratio of the output power produced by the machine to the input power. So basically the efficiency given by this Greek letter E is the power output divided by power input. So this is what is known as the efficiency, and it must be less than 1. So if we have an efficiency of equals to 1, it means that the power output is equal to the power input, which is not going to happen in the real world, because there must be power losses to surroundings in form of various kinds of energy like heat and so on. So the efficiency of a mechanical machine must be less than 1. Let's look at an example problem. If the contact surface between 20 kg block and the ground is smooth, here it means that we have to neglect the friction. So friction is not going to be counted in this case. Determine the power of force F. We have the force F here when t equals to 4 seconds. Initially the block is at rest. So first we're going to draw the free body diagram. This block or box here has the weight pointing down, the normal force pointing up, and the force F here we can break it down into components of X and Y. So we have 30 times 4 over 5 for X component, and 30 times 3 over 5 for Y component. And as you can imagine the motion of the box, it is moving to the right, which means that the only work is done in x-axis. So basically the weight, the normal force, as well as the component of force in y-axis, they are all not doing any work. only this force here, 30 times 4 over 5, is doing work. So if we write the equation, this comes from what we have learned in chapter 2, force and acceleration. Fx equals to m times ax. So we have 30 times 4 over 5 is equal to 20 ax. So we can solve for the acceleration in x-axis to be 1.2 meter per second square. Then we know that this acceleration here is constant because the force here is constant, therefore the box will move at a constant acceleration. So we can use the equation for constant acceleration to find the velocity in this case, because remember, we want to calculate the power. The power is equals to the force times the velocity. So we need to find what is the velocity at time t equals to 4 seconds. So v is equal to v naught plus ax times t. V naught, we know it is equal to 0 because the block is initially at rest. So we have ax is 1.2, t is 4 seconds. So v is 4.8 meter per second. And finally, we can calculate the power by multiplying the force in the component of force F in x-axis, because remember the component in y does not do any work, so we can neglect this component. So 30 times 4 over 5 multiply with 4.8 meter per second, so we have the power equals to 115.2 watt. Okay, let's look at the next example. We have a 50 kg load at A hoisted up by a motor M, so that the load has a constant velocity of 1.5 meter per second. Determine the power input to the motor, which operates at an efficiency of E equals to 0, of epsilon equals to 0.8. Okay, so now we have the efficiency of the motor given. So what we want to find is what is the power input to the motor. Remember, the efficiency is the power output divided by the power input. So now we can draw the free body diagram of the load of the box here, because this is what we are interested in. We have the weight pointing down and we have the tension pointing up. Okay, so now the motion is in y-axis, so we don't have to consider the equation of motion in x-axis. So we have total force in y-axis is equal to MAY. Okay, and we know the velocity in y-axis is given as a constant 1.5 meter per second. Therefore, AY equals to 0 because V is constant. Okay, so we have the tension pointing up positive minus the weight 50 times 9.81 is equals to 50 times 0, which is equals to 0. So we have the tension equals to 490.5 Newton. Now we can determine the output power by this tension here, that is multiplying the tension T times the velocity, which is given 1.5 here. So we have the output power as 735.8 watt. But this is not what we want to find. We want to find out what is the input power input to the motor. And since we have the efficiency equals to 0.8, so we know that the efficiency is equal to P out over P in. P in is the one that we are interested in. So then we can have P in is equal to P out, which we have here 735.8 divided by the efficiency of 0.8. So we have P in equals to 919.7 watt. Okay, so this is the input power. Okay, so that is all about this subtopic. In summary, we have learned about the power and efficiency of a machine or an engine, and we have we have been looking at how to solve several problems related to power and efficiency. So I would like to thank you for listening to this, and I will see you again in the next video. Thank you.